Alright, AP Chemistry kids, let's go ahead and start talking about the different parts of a chemical equation and then how to balance out that chemical equation. Let's start with a basic setup that we have right here. We're having H2 plus O2 reacts to form H2O2. You should recall from CP or HL chemistry that anything on the left side of the arrow is considered the reactants. These are the things that are going to undergo reaction. And then on the right side of this arrow here, which is the yield arrow, these are the products. This is the result of the chemical reaction. Now let's talk about some of the little mini things in here. The numbers that appear in front of the chemical formulas are known as the coefficients. And the coefficients tell you the number of molar equivalents of that substance. So for instance, in this case of H2, we have 1 molar equivalent of H2 reacting with 1 molar equivalent of O2 to produce 1 molar equivalent of H2O2. Now, in CP and HL chemistry, we put these ones in here to help you keep track of your coefficients. We will not be doing that in AP. You should know if there's not a coefficient in front of any of the formulas, then 1 is implied to be there. The subscript tells you how many of that atom are present. So in this case of oxygen, it's O2. There are 2 oxygens present in this atom. There are 2 oxygens present, or 2 hydrogens present for H2, and then in H2O2 there are 2 hydrogens present, 2 oxygens present. Okay, so pretty straightforward with the different parts of the chemical reaction, and I believe we already went over the yield arrow. The yield arrow could be one-sided like this, or it could be double-sided when we're dealing with reactions at equilibrium, and we'll talk more about double-sided arrows later on in the year. What is the point of balancing a chemical equation, ladies and gents? Well, the law of the conservation of mass says we have to do it. Matter is neither created nor destroyed, so the number of atoms on both sides of a chemical equation must be the same. Okay. This is why we balance chemical equations, and we will only change the coefficients to balance it out. We will only change the coefficients out in front. We will never change the subscripts. If you change the subscripts, you're going to change the element, and you're not allowed to do that because it's neither created nor destroyed. So you can't just change this to a 1. It's not allowed. There are some mathematical tricks that you can use to help you get the correct coefficients, and we'll talk more about that in just a sec. Let's balance this first one. This is kind of an easy example. K, potassium, reacts with magnesium bromide to make potassium bromide and then magnesium metal. The equation is clearly unbalanced because I only have 2 bromines on this side and I've got 1 over here. But let's go ahead and get an inventory of the atoms on both sides so that we know how to balance this. Okay. On the reactant side, I have a potassium, I have a magnesium, and I have a bromine. Okay. Now I'll go through and, before I do that, once you get an inventory of the atoms on one side, the law of the conservation of mass says you must have the same list on the other side. So once you know one side, you can just copy the list over to the other. Now we need to go through and count the atoms on both sides and see where we need to make adjustments to balance this equation out. On the product side, I have 1 potassium, 1 magnesium, and 2 bromines. On the this is the reactant side. On the product side, I have 1 potassium, 1 magnesium, and 1 bromine. Now, law of the conservation of mass says these numbers need to be the same on both sides, and they're not. Okay, so we need to fix this. We don't need to worry about the potassium, we don't need to worry about the magnesium, but we do need to worry about the bromine. Okay, so we are going to have to come up here to KBr, and we're going to throw a coefficient out in front that is going to change this bromine to 2. Now, there's already implied to be a 1 here. So what number times 1 will get this to 2. Well, it should be 2. So if I throw a 2 out in front, there are now 1 times 2 bromines, that's equal to 2 bromines on that side. Okay? But we are not done. This coefficient applies not only to the bromine, but it also applies to the potassiums as well. I now have 1 times 2 potassiums, and so there are 2 potassiums on that side as well. Now we've successfully balanced the bromines, but we unbalanced the potassiums, and that's not really a big deal. We have more potassium on this side than we do this side. We can easily add more over here to balance this out. There is 1 potassium here, so what number can I throw out in front and multiply it to get it to 2? 2. And now everything is balanced. Okay? 2 potassiums, 2 potassiums, 1 magnesium, 1 magnesium, 2 bromines, 2 bromines. We're good. In CP and HL chemistry, we told you to go ahead and stick 1s out in front. Don't do that in AP. It's we're big kids now, and we don't need to do that. The 1s are implied to be there. Okay. I really wouldn't do it. It's not incorrect, but the readers for the AP exam are going to kind of look at that and wonder why you're doing it, and if they wanted to have a problem with it, they could probably mark you off because it's not done conventionally. So don't stick the 1s in, just leave them off. Let's do another example. This one's going to be a little bit more difficult, okay? So go ahead and pause the video and see if you can try this more advanced one on your own, and then we will go over it. Alrighty, let's go ahead and go over this one now. As always, we are going to start with an inventory of the atoms on both sides. I know on this side I have an aluminum, I have a bromine, I have a potassium, I have a sulfur, and then I have an oxygen. Once I have the inventory list on one side, it automatically applies to the other side as well. And now we need to go through and count our atoms. On this side I have 1 aluminum, 3 bromines, 2 potassiums, 1 sulfur, and 4 oxygens. On the other side, I have 1 potassium, 1 bromine, 2 aluminums, and now here's where things are going to get a little tricky. This 3 on the outside in parentheses applies to both this oxygen and this sulfur. And we are going to multiply this subscript by the subscripts on the inside. So that being said, the total number of oxygens we have are 3 times 4 oxygens, which are 12. 3 times 1 sulfur, which are 3. Clearly the equation is unbalanced, so let's go ahead and balance this out. You can technically pick any element that you want first. Typically oxygens are best to save last, and that's for anything that you balance. I'm going to go ahead and start with the aluminums first just because they're listed first. We have 2 aluminums on this side, only 1 over here, so I have to add to this side. Let's go ahead and see what we can do. If I've got 1 aluminum here and I need to get to 2, what number can I multiply 1 by to get up to 2? Well, 2, of course. So if I put a 2 out in front, I now have 2 times 1 aluminum. There's 2 aluminums there. But I also changed the bromines as well, okay? Because this 2 coefficient out in front applies to bromine, and I now have 3 times 2 bromines, which is 6 bromines on that side. Okay. So the aluminums are taken care of. Let's go down the list now. Let's do the bromines. Let's try those. I have 6 on this side and 1 over here, so I need to add to this side. And the place to add bromine at is going to be up here. So what number can I stick out in front that will multiply by 1 to get to 6? Well, obviously it's going to be 6. So 1 times 6 is 6. Alright, and then we're taking care of there. The bromines are balanced. But this coefficient out here applies to this K as well. So we need to change that too. I have 1 K times 6. This is now 6. A lot of people forget that once they, in compounds like this, they balance one and forget to go back and change the other. Can't forget to do that. It'll throw you off. Alrighty, now let's go ahead and do the let's do the sulfurs. Yes, of course. We have 3 sulfurs on this side, 1 over here. So I'm gonna need to add to this side. Okay. Let's go ahead and let's see. We've got 1 sulfur here. What number times 1 is going to be 6 to get it to, or what number times 1 is going to get to 3? We need 3 sulfurs. I'm going to put a 3 out in front here. I have 3 sulfurs, but this 3 also changes the oxygen and the potassium. The potassium is now 3 times 2, which is 6, and the oxygen is now 3 times 4, which is 12. And if we go through, is everything balanced? Oxygen's 12, sulfur's 3, potassium 6, bromine 6, aluminum 6. I think we're good. Alrighty. We are going to run out of time for this part, so I will do the second part, which is balancing a combustion reaction using half coefficients in the next part. So stay tuned.